This is AP Calculus, Lesson 1-3, estimating limit values from graphs. Some of this we've already touched on before, but I'm going to make sure you get a good sample of some different types of graphs and understand what's happening with their limits. In this first one, I think we did this example in the last section, but I wanted to show it to you with graphing. Now we learned in the last section that we could take whatever x is supposed to be approaching if we have the function and plug that number into the function, and if we get a nice integer answer, then that will be our answer, but I wanted to show you what that looks like with a graph. So if we take 3 and we put it in for x here, 3 plus 2 is 5, so the limit as x approaches 3 is going to be 5. But if you look at that doing the graph, the graph of f of x equals x plus 2 is a linear function. The y-intercept is 2, the slope is 1, so we go up to 2, up 1, right 1, we've got that linear equation. So if we look at this graph and where the graph is approaching at the 3, okay, 3 is right here on my graph. It looks like 3 is at 5, and if we look at what that graph is approaching as x approaches 3 from the right and x approaches 3 from the left, that y value is the same in both directions. And that's extremely important when you're dealing with graphs, when you're trying to find limits. It has to approach the same thing from both sides in order for the limit to exist. And in this one, you can see that it does. The y value that this is approaching from the right and from the left is the same. It's approaching the y value of 5. So the limit as x approaches 3 for f of x here is 5. If you look at this next example, we did one similar to this in the last section. It says find the limit as x approaches 0 of g of x. So this is the function of g of x, and it looks like at x equals 0, we've got a jump in that graph. So if we're considering what the limit is approaching from the left and from the right, because we have to approach from both sides, if you look at from the left, this graph appears to be approaching the y value of 2. From the right, this y value appears to be approaching -2. It's approaching something different from the left as it is from the right. So we cannot say that as x approaches 0 that the limit exists, because it's approaching something different from both sides. So the limit as x approaches 0 of g of x does not exist. Okay? Now look at this one. It says the limit, find the limit as x approaches 2 for g of x. Well, as x approaches 2, that's putting me right here at this point. So if I look from the left, as x approaches 2, it looks like my y value there is going to be -2. And from the right, as x approaches 2, it looks like my y value again is going to be -2. Since it's the same from the left and from the right, then my limit as x approaches 2 is -2. Then they're asking me here to find g of -1. Well, you learned in algebra that g of a number, g of an x value, is equal to the y value at that x coordinate. So if you look at -1, what is the y value of the graph at the x value -1? It's at 2. So g of -1 is just 2. So it's important to understand the difference between limits and what g of x is. G of x will represent an ordered pair, and the limit is what the y value is approaching from the right and left of a specific x coordinate. Next, let's talk about what happens with infinite limits. Sometimes your graph is going to go either up or down infinitely, depending on what function you've been given. So here, this is the function h of x, and I'm asking you to find the limit of h of x as x approaches 0. Well, you have to consider both directions. You have to consider what's happening as we approach 0 from the left, and you have to consider what's happening as you approach 0 from the right. Looking at it from the left, it looks like it's going to go down infinitely. So it looks like it's approaching -infinity from the left. From the right, it's doing the same thing. It's approaching -infinity from the right. So my answer there is going to be negative infinity. For the next one, this is a function f of x. They're asking us to find the limit of f of x as x approaches 0. And again, we're going to have to consider what's happening as we approach from the left and as we approach from the right. Well, if we approach from the left, this function is going down infinitely. So from the left, it's approaching negative infinity. As we approach from the right, it's approaching positive infinity. So for this one, even though they're both some form of infinity, they are in fact opposites because one's approaching negative infinity, the other is approaching infinity. So since these two are not approaching the same thing, for this one we would have to put does not exist. Now, these two kind of hint at one-sided limits. A one-sided limit is what happens when we approach from just one direction, okay? And so that's what we're going to talk about next. If we just approach from the left, well, from the left, this would be negative infinity. If we just approach from the left here, the limit would be negative infinity. If we just approach from the right, it would be negative infinity here. If we just approach from the right, it would be positive infinity. And sometimes that's what they're going to ask. They're only going to ask for one-sided limits, either what's happening as you approach from the right or what's happening as you approach from the left. And in order to signify that, what they will do is right here with the number that we are approaching as x approaches something, if they want you to approach from the right, they will put a little plus sign in there. Plus kind of signifies go right, right? So if we're looking at something from the right, we're going in that direction. If they want us to find the limit as something approaches an x value from the left, they will put a little negative there as we approach from the left. Okay, so that's how you distinguish between right and left one-sided limits. Here I have function p of x. P of x is a piecewise function. It has a jump right here at x equals 3. It's an open circle here with a linear equation or a linear function going toward the left, and the jump here is at 3 still, and it's got a linear function going toward the right. And here it's asking me to find the limit of p of x as x approaches 3. So what we need to do is see if we can tell what x is approaching, or see if it's approaching the same thing from the left and from the right. Well, as we look from the left, it looks like from the left at x equals 3, y is approaching 4. Okay, so from the left, y is approaching 4. Doesn't matter that that's an open circle there. It's still approaching 4. And then from the right, as x approaches 3, it looks like that's approaching 5. So from the left, it's approaching 4. From the right, it's approaching 5. So when we're finding the limit as x approaches 3, just as x approaches 3, since those two things are two different numbers, we have to say the limit as x approaches 3 does not exist because it's not approaching the same thing from the right and from the left. But look down here. Now I've got some one-sided limits, and they're going to separate some of the problems sometimes. They'll say find the left-sided limit, find the right-sided limit, and then find the limit of the whole thing. If these two are not the same, then the limit as x approaches that number does not exist. But your one-sided limits could exist, even if this one doesn't. So if we're approaching 3 from, that's a negative, so from the left, as we approach 3 from the left, our y value is going to be 4. So the limit as x approaches 3 from the left is 4. As we approach p of x, or the limit as p of x approaches 3 from the right, as we approach 3 from the right, it looks like that's at 5. So the limit from the right is 5. But the limit as x approaches 3 alone doesn't exist because these two things are not the same. Here I have a piecewise function g of x, and you notice here this looks like sort of an absolute value type equation. We've got some holes in the graph. This looks like maybe half of a parabola here. We've got some ordered pairs. So in this one, they're going to ask us to find several different things. And I've got what we're looking for here. The first one says find the limit as x approaches 5 for g of x. So the limit of g of x as x approaches 5. So we're going to look at that from both sides. The limit as x approaches 5 from the left, well, it looks like the limit is approaching -4. Again, it doesn't matter that it's an open circle, that's still what it's approaching. And then from the right, it looks like the limit is approaching 0. The y value is approaching 0. So the limit as x approaches 5 does not exist because they're not the same from both sides. The limit as x approaches 8. Okay, if we're looking for the limit as x approaches 8, we have to consider from the left and from the right. Well, it appears that from the left, as x approaches 8, it's approaching 3. Doesn't matter that it's an open circle there, it's still approaching 3. And then from the right, as x approaches 8, it looks like it's approaching 3 on that side as well. Even though there's a solid dot here, that doesn't matter. It's still from the left and from the right, both of those are approaching 3. So the limit as x approaches 8 is 3. The limit as x approaches 0. Okay, here's x approaching 0. Well, from the left, it appears that it's approaching 6. From the right, it appears it's approaching 6. So the limit as x approaches 0 is 6 because it was the same from both sides. Next, the limit as x approaches 3. The limit as x approaches 3. Here's 3. So from the left, it looks like the limit is approaching 0. From the right, it looks like the limit is approaching 0. So that limit is 0. Next, the limit of g of x as x approaches -4. All right, here's -4. As x approaches -4 from the left, it looks like the y value there will be 0. As x approaches -4 from the right, it looks like the y value there is going to be 0. So again, that limit is 0. And then look here what it's asking for. It's saying find g of 8. It says find g of 8 and find g of 5. Okay? The answer to g of 8 and g of 5 is not going to be any different than it would have been in Algebra 2 or pre-calculus. Limits are different than finding the y value at a specific x coordinate. So if they ask us to find g of 8, that's the solid dot when the x value is at 8. So g of 8, x is 8 right here. The y value, the solid dot at 8, is at 1. So g of 8 is at 1. Now notice, the limit as x approached 8 was at 3 because it's approaching 3 from the right and left, but the solid dot is on 1. So it is okay if you have g of 8 and the limit of g of x as x approaches 8 being different numbers. That is very common in calculus because the limit is what the y value is as x approaches a certain number from the left and the right. Doesn't matter that on the graph it's not a solid dot. So I want to make sure you understand that that is very different. Those two things are asking for very different things. G of 5, find g of 5. Well, at 5, right here, the solid dot is at 0. Solid dot is at 0. I could see people accidentally putting -4. So be very careful there. It's where the solid dot is. If there's no solid dot, if they were both open, we would say does not exist because there's no solid dot that gives us the y value at that specific x coordinate. But the big thing that you need to take away from this is you can have the limit as x approaches a number be different than f or g of that number. The point that that number is at that x coordinate can be very different than the limit at that x coordinate. Real quick, I want to talk to you about unbounded limits. Basically, if the limit approaches infinity or negative infinity, it's said to be unbounded. And we've talked about unbounded limits, but we haven't called them unbounded. Here, if x is approaching 0, the limit from the right and the left is both going to be infinity. So the unbounded limit there would be infinity. Here, from the left and right, if we're approaching 0, it would be negative infinity. Here, approaching 0 from the left would be infinity. Approaching 0 from the right would be negative infinity. Approaching just 0 would be, does not exist because it's approaching two different things. And then this unbounded limit, approaching 0 from the left would be negative infinity. Approaching 0 from the right would be infinity. Well, if you're just approaching 0, the limit would be does not exist because it's two different answers. And then the last thing in this section that we're going to talk about is oscillating functions. And a good example of an oscillating function is the limit as x approaches 0 of sine of 1 over x. And this happens a lot with your trig functions. An oscillating function is a function that just oscillates between two numbers, and this one's oscillating between 1 and -1. It just continually goes up and down, and you really can't tell what the limit is because it's oscillating. It's going very quickly, and you may, if you have a graphing calculator, you could put that in the graphing calculator and then make your x values, the boundaries between your x values, very small. Like maybe you want to go from, I don't know, make negative pi over 8 to pi over 8, and you'll be able to see that oscillating behavior on the calculator. It's not something that we see real often. Usually if they want you to say it's oscillating, they will give you a picture that looks like this where you can see it's going up and down very quickly. Other than that, you just need to understand what oscillating is. It's just something that bounces between two y values in a small boundary of x values. In this example, I'm giving you a piecewise function, f of x equals x squared when x is less than or equal to 2, 8 minus 2x when x is between 2 and 4, and x equals 4 when x is greater than or equal to 4. And we're going to graph this piecewise function and then talk about some different limits of that piecewise function. So you need to understand how to graph these, and so that's the purpose of doing this problem, is to make sure you understand how to graph them. If you think about x squared, f of x equals x squared, well, that's the parent function of a parabola. So if we were to graph that, it would be at 0, 0, 1, 1, 2, 4, 3, 9, and then symmetry would take care of the other side. So that graph of x squared would look something like this. But if you look at the x values that are associated with that graph, they only want x squared when x is less than or equal to 2. So at x is less than or equal to 2, so from right here on, that's where we want the x squared function to be represented on our graph. So this portion of it is not in our graph. Okay? Then they say from 2 to 4, we want the function 8 minus 2x. Well, we know we want this to go from the x value of 2 to the x value of 4. So to get that portion of the graph, all I really need to do is plug 2 into this and get the ordered pair for it. So if I plug 2 in, I have 8 minus 4, which is 4. So that would be at 2, 4, and that's actually the same point there, so that makes it nice. It's going to be continuous at that point. And then if I plug 4 in, 8 minus 8 is 0. So at 4, that gives me 0. So that portion of the graph goes right there. That at 2 is an open circle, but it's a closed circle because of what we had right here. And then at 4, it does not equal 4. It's an open circle at 4 because it says it's just less than 4. So we need an open circle on our graph there. And then here for 4, y equals, or f of x equals 4, that's a horizontal line at 4. From 4, any value of x that is greater than or equal to 4. So from 4 on, so 4, 4, to the right, we're talking about that horizontal line. Okay, it kind of goes off our grid there. So that's the graph of this piecewise function. And then they might ask you, or for what values of x would the limit exist? Well, we know that the limit exists everywhere that if we approach from the right and the left, we have the same limit. So the only place we would not have a limit is where we have a jump in the graph. And we have a jump in this graph at the x value of 4. So if you think about it, the limit of this piecewise function everywhere except 4 would have a limit. So when they ask us where does the limit exist, we would say it exists from negative infinity to 4, and then from 4 to infinity. I'm using parentheses here at the 4 because the limit does not exist at 4. So it does not include 4. There is no limit at 4. That's why I'm using parentheses here. That's set notation. If I were to use brackets, then it would include the 4. Okay? And anytime we have infinity, we also use parentheses. That should be review. You should have learned that in Algebra 2 and in then continued that with your pre-calculus. So we will do more set notation as we go. But if it's included, you use brackets. If it's not included, or it's at infinity or negative infinity, you use parentheses. Okay, hopefully you can see this pretty well. I've got here a graph. It's a piecewise function graph. I've got some holes. I've got some solid points. And then over here, I'm asking you to find the limit as x approaches these values. And then here, I want you to find f of -5, f of 6, f of -8, and then the limit as x approaches 0. I didn't get that in the table there. So go ahead and pause the video and see if you can figure out those values. Okay, real quick, I want to answer those questions. The limit as x approaches -2 is 1. The limit as x approaches -5 is 6. The limit as x approaches 2 does not exist because there's a jump right there. The limit as x approaches 6 is 4. The limit as x approaches 4 does not exist. There's a jump in the graph. The limit as x approaches -1 is 2. The limit as x approaches -8 does not exist. There's a jump in the graph. F of -5 is 3. F of 6 is 4. F of -8 is 3. The limit as x approaches 0 does not exist because from the left it's approaching infinity and from the right it's approaching negative infinity. So hopefully you got all those right and understand limits pretty well. We'll do some practice.